currently climate change is the largest problem humanity is facing. And this became even more relevant in recent years with the increase in extreme climatic events, not somewhere in the remote part of the globe, but also here in Europe. As part of climate change service, at ECMWF, we produce climate bulletins on a monthly basis, describing the state of the climate and highlighting and explaining extreme events, not just in Europe, but globally. Also, together with our partners from European Met Offices, we produce executive summary of yearly state of European climate. The software and the data processing techniques we use are our internal ECMWF, and this makes it difficult for other users to reproduce our data and visualization. So the main purpose of Sketchbook Earth Challenge is to produce Jupyter notebooks with training material, explaining how to process data, how to calculate various quantities, and how to visualize using open source Python packages. So I'd like you to welcome Nikos and Niklas, who will explain Sketchbook Earth.
Yeah, thank you. Thank you, Irina, for introducing. And my name is Niklas. This is Nikos. Eddie, our other mentor, cannot be here today, but also thank you to him for support through our journey. I think, yeah, when we're right now trying to get up the. Yeah, we also. Yeah. So I hope you did not use all the luck for showing live demos, because we also need it. Yeah, great. Cool. So, and actually now I already need your support to switch the screens, because now, before we head into this presentation, I would like to get a little bit interactive with you. So please get out your mobile phones or a computer, head over to Menti, and when we go now to the next slide, you still will see the code, hopefully, on the screen. And then I try. Oh, I already see people voting. So you probably already see the question, which is really great. We don't see it here yet, but you apparently see it online or when you hit the Menti. So the question is, will you find more sea ice in terms of the rear? A, in the Arctic, B, in the Antarctic, or it depends on the season. So we see now the result. Cool. So it's quite mixed. Yeah, we'll wait a bit more, but maybe somebody who's for Arctic, maybe can you raise your hands? Arctic, anyone here? Arctic? Okay, some very shy hands there. Antarctic, are you more brave? Yeah, a bit more brave. Why? Anyone wants to tell me why Antarctic? Just a feeling, gut feeling? Yeah. Yes, great. Actually, I also thought in the beginning it would be more Arctic, but now when we see the result, maybe you can show the final answer. You see it. So the final answer is it depends on the season, which you will also see in a bit. And to be clear, I mean, we're talking about a fair comparison. No? We're comparing like Arctic winter to Antarctic winter, so not like January to January. Okay, so let's go to the next question. Last one, yeah, and then I get started. Do you know what is the current sea ice extent anomalies in the Arctic and Arctic in terms of standard deviation? So if you have like 0, it basically means, okay, that's what we would expect right now. And I think you have a range from -5 to 5. you think about your Gaussian distribution, like ±2 is already you're at the outer edges of your distribution. Everything beyond is really extreme.
Your reference.
The reference time frame is going, good question. It's from 1980 to today. No, it's a reference period. Oh, sorry, 81 to, is it? It's the current actor. It's a current reference period, 91 to 2020. Climatology, yes. Okay, I see the answers are trickling in. Interesting. Okay. Okay, I see, but already from the results, I can see you follow the news. That's cool. So we have like a couple of more seconds to go. And when we hit now the final answer, so yeah, we are. So, okay. So we try to remember the names, the numbers, but we'll get back to it at the end of our presentation, and we'll actually derive the answer hopefully live. So let's see if it works or not. And now we go back to. Okay, cool. So here you have the answer for the first question. You see this animation showing the sea ice extent in the Arctic and the Antarctic from 1990 to 2020. And you can see, just note briefly that the y-axis has a slightly different scale. So for the Arctic, it goes up to 20 million square kilometers, while for the Antarctic, it goes to 25 million square kilometers. But you can see that in September, so the Antarctic winter, we have more sea ice compared than in the Arctic winter. And in the Antarctic summer, we actually have less sea ice than in the Arctic summer. And I already figured from the responses that you gave that you have also like followed the media. So you have probably seen that this year was very terrible for sea ice extent in Antarctic. For the first time ever, we actually have really extremely low values, and it was reported by The Economist, BBC, The Guardian. And you can see from the figures, well, they are basically showing the same, more or less, data, but in a different way. So the question is a bit, if we want to report on these climate extremes and these events, where do we get the data from? And Irina already introduced it a bit. One of the prime examples, in particular for Europe, but also globally, is the Copernicus Climate Change Services. And they provide, basically, they provide intelligence reports about climate events. And in particular, they have 4 categories, or 4 columns. The first are the monthly climate bulletins, which shows monthly updates of global, but also European, Arctic, and Arctic climate situation. Then we have an annual report about the European state of the climate, and also on an annual basis, the climate indicators, which are more like broad-term indices describing the overall climate on our Earth. And finally, a report also annually published that focuses on specific events like heat waves in Canada or wildfires. And just to give you a brief idea of how it looks like, so if you would go right now to the climate intelligence section of Copernicus, and then open the climate bulletins and go to sea ice, then you will find this figure. I just converted the colors, but it's really just like copied this figure, basically. And you can see that Antarctic sea ice extent was dramatically low this summer. So at that step, I'd like to take a brief step back and think about who is possibly interested in this information in our society. And you can think about 6 categories. So we have scientists, we have educators, teachers, professors. Then we have environmental consultants. We have journalists or media outlets, policymakers, and obviously also general public. And I'd like to think about the target audience sometimes also in a different way. It's not too complicated. You can think about it. The one dimension is policy influence, like what is the potential of the target group to influence our policies, and the other is science literacy. So how used is the target audience working with scientific data, with programming and so on. And the general public, well, you can argue about policy influence perhaps, but I would say it's rather low on both scales. But then the other categories, you can more or less like plot them on a line. And well, don't pin me down on this figure because it's really qualitative, you know, it's like, it's not very scientific. But in general, you see that scientists clearly have like a high degree of science literacy, but then you go down the chain to educators, government consultants, journalists, and policymakers. And our project basically tries to improve this information transmission from going from the one dimension to the other dimension, so increasing basically how to transmit the information from scientists to the policymakers. And to make this clear at one example, so let's take one particular example here. Consider you're a journalist and you want to report on this year sea ice reduction in Antarctica. And so you go to the climate bulletins, you see this figure that we already seen earlier. You think, okay, wow, very extreme. I need to bring this out to society and I need to tell the story. But well, first is I see the data only goes until the end of August. Now we're almost at the end of September. So I need the most recent data perhaps to see if it also continues the trend. And how can I reproduce the figure? Because Guardian, BBC, they all have like different corporate designs that they have to fulfill. And this is what we then created in our challenge. So a solution that allows users to reproduce different figures. And there are two main characteristics. So first, it must be fully reproducible. So we only use open data from the Climate Data Store, Atmosphere Data Store, Marine Data Store, open infrastructure. So Jupyter Notebooks, Binder, Google Colab, Wikio, and open software. So the entire Python environment, which, yeah, with the common packages from Xarray to CartoPy and Matplotlib and Seaborn. And the second characteristic is it must be transparent. So we not only want to deliver recipes, but also make clear and explain exactly step by step how to download the data, how to access the data, what are the necessary steps to pre-process the data, and finally to visualize the data in the way that it is shown also in the climate intelligence reports. And in all this, we tried to follow with this approach of having like simple instructions, but yet flexible enough so that the user can really use it and it really adds value to users. So here you can see the final results. You can find the book published at ECMWF codeforEarth.github.io/Earth. And just to give you a brief example, like when you will go through this book, you will find what I mean with flexible, specific code cells that allow you to define your region of interest or to adapt the climatology reference period to your needs. So then more bit in concretely, what can you find in that sketchbook? Now you can find how to reproduce selected figures from monthly climate bulletins, climate indicators, and the ESOTOP report. We show in these tutorials how to pre-process different climate variables, so ranging from greenhouse gases, CO2, methane, temperature variables like sea surface temperature, but also surface temperature, sea ice, sea level, and how to derive indices of large-scale patterns, in particular here ENSO and the North Atlantic Oscillation. And finally, also a dedicated notebook to how to create interactive plots and animations, something that goes also in line with what we've seen from the group before. So you can see check out the repo here, but I think more interesting, okay, that will come afterwards. Just one more example, which also showed like during last presentation. So if you would go right now to the climate intelligence reports of the Copernicus and click on climate indicators and then go to the greenhouse gas section, you will find this figure here, which shows the global concentration of atmospheric methane, together with the annual growth rates. And you can see here on the right-hand side our reproduction that has like the entire associated notebook at that link here below. So, and now we will go to a live demo, showing you how, like, giving you one example. I cross my fingers that it works. You can also, if you like, if you have your computer online or maybe even with your mobile data, follow the instructions. It's the example that we plan to do just will take a couple of megabytes, so that should work. And I would hand over at this point to Nikos.
Yeah. So hi again. From my side as well. So let's try to see that we are also like the previous thing. Let's go to the link. So this is how the notebooks look like. This sketchbook we have created. We have a background, the objectives. Normally for every book you can see links to the relevant reports or the bulletins where the plots are made from related to these particular reports. We refer about which variables we're going to use. Here. Yeah. I have some nice overview data sets where you can find the data. They are available also in the CDS and climate data store. And here also we have some links that you can run. Those is good also in the cloud, not only locally. And let's use Google Colab in our case just because it's a bit faster. Here you see also we have some information about how to run code. So it's the same book as before. Now it's just that we will start running it here live. And just because we are in the Google Colab, we need to add some libraries. So bear with me for that. So that's the only drawback if we collab. That's supposed this. I didn't prepare Italian course. I'm sorry. Anyway, till it makes the installation, hopefully, we can maybe have a look a bit at how the more, let's say, user-friendly version looks like. And the thing you can start with maybe, of course, is how to execute all these books. Either again in the cloud with Binder Google Colab, which again here we need to install some libraries which are not installed in the environment, or also in the local machine. You can clone the repository that is on GitHub. We have also the environment with all the libraries needed. Takes a bit of time. So what Nicholas mentioned, we have these different sections, the greenhouse gases, and these are two, let's say, chapters that give some information about, show us how to download data, for instance, from the climate data store, how to process, and at the end, we have, for instance, some of the figures, like what exactly we showed before. So you follow such a tutorial, you can have this particular plot. Maybe because this is still taking some time, but I think we will make it.
When this is going to be installed,
to the actual one, right? Okay. Yeah, let's maybe have it here. So what we plan to do now, which we will do it, is okay to install the packages. So the first section of the important packages, make some configuration for the DAS, which is not needed actually for our particular case, but for the rest parts of this notebook is important because there's a lot of data. So we need to chunk it and use DAS for memory efficiency. Here, it's again what Niklas showed before. We can define the reference period. So users can play around and change a bit the reference period and see how the results are changing. One more cell where we create the files where we store the data we derive. You can see here how it looks like. And now this part is some, let's say, data consuming a lot of data for this section. So we can let's see. The name for getting library. All right. So as I was telling before, we can have this task a bit information, then and of course we try to have some explanations for every cell. So any user, regardless the level and experience they have, they can understand a bit what's the aim and what can be done. And now let's go to the CI's extent. So again, what we asked all of you actually for the Mentimeter before, which requires only a couple of megabytes as Niklas said previously. So we're gonna take some data from the Met Office of Norway, which they have some time series with the extent for actually Antarctic and the Arctic. And we see here we read some X-rays. Again, like most of the other teams, we also used X-rays. It's a very nice library. Make some small processing by removing here some unnecessary variables in our case. We combine all the information in one data set. And here we can plot, for example, the time series. So this is time series of the Arctic and the Antarctic, which is the color CI's extent. And again, you can see here the results of the first question that we showed also with the animation, that depending on the season, we see essentially that Arctic has less variability. So the lower of Arctic is higher than the lower of the Antarctic. That's why we're season dependent, which the Arctic or Antarctic has more CI's extent. And now, because for example, we want to make this information about the standardized anomalies, the CIs we need to make some pre-processing and reformatting the data to have these nice two variables, year and day of the year, so we can play around with climatologies, which for example we here by getting the mean value of the CI's extent. Here now we have some, let's say, auxiliary functions for the plotting, so they can help us and we can use them all the time for all the similar plots we would like to do. And now we can select the regions, as Niklas said before. We try to make it user friendly, to have flexibility to select any region that is available on the data set. In this case, for example, it's Antarctic and Arctic for this particular step. And here, for example, we see the picture that was initially, but we have the updated information, right? The most recent data that available from the Norway's Met Office. So like this, we can have any journalist that wants to have the up-to-date data. For this node, for example, for this particular variable, can get it. But this is the actual time series, and we had in the Mentimeter the question about the standardized values, so how different from the climatology there are. And here we calculate the anomalies by removing the median. We can see here again the plot, again up to date, the most recent values. And if we make the standardization, we can answer our question in Mentimeter. So this one is for the Antarctic. And we see that now we have the deviation of around -3. And then we go to the other to see the results. And if I change, so for the Antarctic it was -3. Now we can run now the same for the Arctic also. So for the Arctic is around -2, -1. Maybe we have Ah, it's from here. How we change to the to see what we replied to see the just to see how the group did. They were close.
Okay, but I remember we had like
2.3 something like that. We lost it. Ah,
So actually, it did not too bad.
not too bad. Maybe we exaggerate a bit in some part. But how can we? We need to have it here. Yeah. So live demo takes a bit of time always, and there are some challenges, but so yeah, this was the result. So we were a bit more extreme on the Arctic and less extreme on the Antarctic. Although actually we have a peak for the Antarctic, which is good. So I think we are well informed. That's yeah. No, I think it's okay. So pretty much this is what we did. We tried to make also a demonstration of one of the sections of our notebook. And we hope that this work will be used by, let's say, general scientists and people who would like to transfer the information closer to policymakers. Yeah.
And also provide feedback. You can always shoot records, so you can maintain it because for the development, in case there is going to be
we aim to invest time throughout the year for improving this service. So feedback is very much appreciated. Thank you.